Okay, so we're gonna start college algebra with just a review of some of chapter 1. We're not gonna review all of chapter 1. Fundamentals. Section 1.4 is about rational expressions. So first, we're gonna define what we mean by rational expression. Then we're gonna talk about simplifying rational expressions, multiplying and dividing rational expressions, adding and subtracting rational expressions, and finally simplifying complex fractions. All a review from what we've done in beginning and intermediate algebra. What is a rational expression? When we say rational, it's from the word ratio, which is a fraction. So when we say rational expressions, it's a fraction of two polynomials. So when you divide two polynomials, you get what we call a rational expression, as long as you don't divide by 0. So p over q, where q is not 0. What's the domain of a rational expression? The domain of a rational expression, p over q, is all real numbers except where q is 0. Why is that? Because if q were to be 0, the rational expression would be undefined. So we cannot plug in any number for x that makes the denominator 0. If it makes the denominator 0, it's not in the domain of p over q. So some examples about rational expressions. X minus 2 over x squared minus 1. Now if you want to find its domain, it's all real numbers except where q is 0. This is q, this equals 0. When x squared equals 1, so x equals plus or minus 1. So the domain is all real numbers except these. So we write it as negative infinity, negative 1, then 1 to infinity, and negative 1 to 1, and then 1 to infinity. Okay? Okay, number 10, page 42 in your text. Again, how do we find the domain of t squared minus 5 over 3t plus 6? You can see from that the denominator is 0 when t is negative 2. So it's all real numbers except negative 2. And that would be the domain. Number 12, page 42. If you have a square root of x minus 1 at the bottom, the domain, again, x minus 1 has to be usually greater or equal to 0, but since it's in the denominator, it cannot be 0, so it has to be greater than 0, which means x is greater than 1. And the domain is 1 to infinity. 1 is not in the domain, because if you put a 1 in there, you get a 0 in the denominator, which is undefined. Now, how do we simplify a rational expression? Again, there's a handout on D2L. Go under handout and you can see the steps. There's a lot of handouts. To simplify a rational expression, you completely factor the numerator and denominator and then cross out all common factors. I'm going to write them down, but I just want you to know that they're all in there. So to simplify a rational expression, the first thing you want to do is completely factor the numerator and denominator of that fraction, and that's why factoring techniques that we learned in Math 1100 and 1150 are extremely important. Okay, so review those if you forgot how to factor, and then cross out all common factors. Cross out all common factors. Okay. Number 18 from page 43. How do we simplify x squared minus x minus 2 over x squared minus 1? Well, this is a trinomial, product -2, sum -1, so it's -2 and 1. This is the difference of two squares, so it's x minus 1, x plus 1. We factored the top, we factored the bottom, we cross out common factors. Whatever is left is going to be my final answer. It's 222, page 43. Y squared minus 3y minus 18 over 2y squared plus 7y plus 3. Again, product -18, sum -3, so it's y minus 6y plus 3. This you can do 2y plus 1, y plus 3, which is y minus 6 over 2y plus 1. Again, if you need to brush off on factoring techniques, I'm going to check D2L if I posted a review of factoring on there. If not, I can do that. I probably will. Okay, then how do we multiply rational expressions? So we did simplifying, now multiplication to multiply rational expressions. Again, you gotta factor everything first. So completely factor all numerators and denominators. So everything has to be factored before you start crossing things out. Cross out all common factors. So you want to completely factor everything, cross out all common factors. Once you're done with these two steps, then you multiply. So multiplication comes last. You multiply straight across. So if you're timesing P over Q times R over S, sorry for the mess, so you do straight across. P times R over Q times S. Alright, so we can do number 30 from page 43. X squared minus x minus 6 over x squared plus 2x times x cubed plus x squared over x squared minus 2x minus 3. So we can factor that. So x squared minus x minus 3 minus 6 is x minus 3x plus 2. This has a common factor x, so it's x plus 2. This has a common factor x squared, so it's x squared x plus 1. This is x minus 3 x plus 1, product and sum. Okay, that cancels out, that cancels out, that cancels out, and you have x squared over x, which is just x over 1 or x. How do we divide rational expressions? To divide two rational expressions, you multiply by the reciprocal. You multiply by the reciprocals. So if you have P over Q divided by R over S, then it's P over Q times S over R. You flip that after you switch division into multiplication, and then this is a multiplication problem which takes you back to multiplication of rational expressions. So when dividing, you gotta do the extra step first, and then you proceed as you did with multiplication. For example, how do we divide 4y squared minus 9 over 2y squared plus 9y minus 18? You want to divide this by 2y squared plus y minus 3 over y squared plus 5y minus 6. So the first thing you want to do is get rid of the division by timesing by the reciprocal, and that's 2y squared plus y minus 3, 4y squared minus 9, 2y squared plus 9y minus 18. Then you divide, then you factor, so this is going to be difference of two squares, 2y plus 3, 2y minus 3. This is a trinomial, it's going to factor into 2y minus 3, and then y plus 6. This one, y plus 6, y minus 1, 2y plus 3, y minus 1. So 2y plus 3 cancels out, 2y minus 3, y plus 6, y minus 1. So what do we have left? We have 1 on top and 1 at the bottom. 1 over 1 is just 1. Now adding and subtracting the rational expressions. Adding and subtracting rational expressions. Well, there's few steps that we need to do to add and subtract rational expressions, and I don't want to write this down because it's time consuming. So if you look at the handout, which is posted in D2L, the first thing you want to do, because you're adding and subtracting, you got to find the least common denominator. And if you forgot, I put the steps here. To find the LCD, you factor each denominator completely. Any factors that occur more than once should be expressed as powers. For example, if one denominator is x squared minus 2x plus 1, and you factor it, it's x minus 1, x minus 1. You need to write it as a power, so it's x minus 1 squared. Okay? List all different factors other than one that appear in any of the denominators. When the same factor appears in more than one denominator, write the factor with the highest power that appears. For example, if you have x squared, x minus 2 in one denominator, and then say x minus 3, x minus 2 squared in another denominator. So to find the LCD, there's x in both of them. You pick the one with the highest power. X minus 2 in both of them, you pick the square, which is the highest power. And x minus 3, even though it's not in both of them, it has to be brought down because we're finding a least common multiple. A multiple must include every factor. I hope I made that clear. And the least common denominator is the product of all the factors listed in step 2. Now to add and subtract fractions with different denominators, you want to find the LCD, which we just went over, and then you want to build up each fraction by multiplying by what's missing from the LCD, and then you add and subtract. Okay, but the hardest part is finding the LCD. So let's just practice that. Number 44, page 43. So how do we add or subtract these two fractions? First, we get a factor to find the LCD. There is nothing to factor at the bottom. So the LCD is the product of these two denominators. And now we want to build each fraction. So we want to times this one by x plus 6, top and bottom, and this one by x minus 4 to get the same denominator. Okay, and once we do that, then we get x squared plus 6x over the LCD, which is x minus 4, x plus 6, minus, distribute the 3x minus 12 over x plus 6 times x minus 4. And now we combine like terms on top, because we're going to write it as a single fraction, because now we can do that since we have the same denominator. So x squared plus 6x, now you got to watch out for this negative. That means you're going to have to distribute it. So it's minus 3x minus negative 12 is plus 12. Combine like terms, x squared plus 3x plus 12 over x minus 4. Usually we factor the top, but this is prime, so that's the final answer. 56 from page 43. X over x squared minus x minus 6 minus 1 over x plus 2 minus 2 over x minus 3. So here we have to do some factoring. This is going to factor into x minus 3, x plus 2. And the LCD, you're going to bring each factor. So x minus 3, x plus 2. We already brought down x plus 2, and we already brought down x minus 3. So now we don't have to write 2 times the first fraction by anything, because it's exactly the LCD at the bottom. If you look at the second fraction, you're going to times it by what's missing from the bottom, which is x minus 3. And this one, x plus 2, times it by x plus 2. So you have minus 1 times x minus 3, and then minus 2x plus 4 over the LCD. Once we have the same denominator, we can combine like terms. So x minus x again, minus x plus 3. And then the minus 2x minus 4 all over 1 denominator. We don't need to write more than 1 now. The x's cancel out, so you get negative 2x minus 1 over the LCD. And that is my answer. Okay, next we're going to talk about complex fractions. And when we say complex fractions, it's fractions within fractions. So it's a complex fraction is a fraction where numerator, denominator, or both contain fractions as well. So it's fractions within fractions. For example, 1 over a plus 1 over b over 2 over a minus 2 over b. So how do we simplify it? See how complex this is? To simplify it, you need to multiply. This is called the numerator of the complex fraction, and this is called the denominator of the complex fraction. So you need to times the numerator and the denominator of the complex fraction by the LCD of all the secondary denominators. So what's the least common multiple of AB? It's AB, so we times by AB or AB over 1. And that's good. So we can clear out all these secondary denominators. AB over 1 times 1 over A is B. AB over 1 times 1 over B is a. ab over 1 times 2 over a is 2b minus ab over 1 times 2 over b is 2a. And that would be my final answer. And let's look at another complex fraction example. 64, page 43. X minus 3 over x minus 4 minus x plus 2 over x plus 1, all divided by x plus 3. So the secondary denominators are x minus 4, x plus 1, and 1. So we want to times by their LCD, which is x minus 4, x plus 1. So we do minus 4, x plus 1. Same thing here, x minus 4, x plus 1 over 1. So this is, we distribute, this is going to clear out x minus 4, and you're going to have x minus 3 times x plus 1 over 1. When you do that, you're going to cancel out x plus 1, so you have x plus 2, x minus 4. Don't forget the negative up front. And at the bottom, it's already factored for me, and nothing will cancel out. So now I got to do some work. I got to foil, and then distribute the negative. So x squared, outer is x, inner is negative 3x. It's minus 2x minus 3, and then minus, again foil, x squared minus 4x plus 2x is minus 2x, and then minus 8. Distribute the negative. X squared minus 2x minus 3 minus x squared plus 2x plus 8, all over the LCD, x plus 1. So the x squared cancels out, the 2x's cancels out, and you get a 5 over the LCD. Trying to save some papers. Okay. Finally, in this section, I want to review rationalizing the numerator or denominator of a fraction. Rationalizing the numerator or denominator of a fraction. In calculus, we need to do that, so to do limits, okay, which is hard to explain right now. But to rationalize a numerator, that means you want to remove the square root from the denominator, okay, or numerator. For example, in order to do that, the steps are, you want to multiply by the conjugate of the numerator or denominator. Conjugate means you switch the middle sign. If it's a minus, you make it a plus. And then you want to simplify. So if you look at 90, page 44, how do we rationalize the denominator for 2 times x minus y over root x minus root y? So the denominator has the square roots, so we want to times by the top and the bottom of the fraction by the conjugate. Why the top and the bottom? We don't want to change the value of the fraction, so we're actually timesing by 1, right? Root x plus y over root x plus y is 1. And again, conjugate means you switch this sign. So if you look at the top, we get 2 times x minus y times root x plus root y. If you FOIL this, you get x minus y, which cancels out, and you get 2 root x plus 2 root y. Now some might say you still have a square root. That's right, but the square root now is in the numerator because the denominator is 1. We removed the square roots from the bottom, and that's what the question was about. Okay, and that will end